And then in the switch 2, this is the switch 2, I'm going to configure a spanning tree because I want to create different STP topology. A spanning tree for instance 2, MST2. This switch is the root primary. And after that, in the switch tree, this is the switch tree, spanning tree, okay, spanning tree, MST tree, then root primary. Actually, every command that you have learned previously with a spanning tree VLAN, you should replace them with the spanning tree MST command, okay? Let me to show you. In the switch 1, okay, I'm going to configure conft spanning tree MST1 root primary. Or if you want, you can use a spanning tree MST1 priority, then priority, okay? Here in the switch 2, a spanning tree MST2 root primary. And finally, in the switch tree, a spanning tree MST3, okay, root primary. That's it. This is our configuration. So easy. Now let me to show you what is happening. You know that now in the MST1, let me to write here because I want to compare with the show commands. In the MST1, we will see that both port of switch 1 are designated port. Let me to write here. This is switch 1. Okay, in the MST0, in the MST1 first, in the MST1, gigabit 01 is the designated port, and also gigabit 02, okay, gigabit 02 is a designated port. Why? Because this switch is the root bridge. Let me to write here, this switch is the root bridge. So easy. But in the MST2, okay, in the MST2, you know that this switch is not the root bridge. First, let me to show you the MST1 status in both switch, in switch 2 and 3 also. This is switch 2. In switch 2 for MST1, the gigabit 01 is the root port, and gigabit 02 is designated port, and this bridge is not root bridge, okay? In the switch 3, about the MST1, gigabit 01 is the root port again, and gigabit 02, okay, is alternate port, and this switch is not the root bridge. It is so easy. This is the story of MST instance 1. In the MST instance 2, let me to show you. In the MST instance 2, you know that the root bridge is the switch 2. Because of that, let me to copy the root bridge here. This is switch 2. And because of that, in MST2, both of interfaces of the switch 2 are designated port. This is designated port, and also gigabit 02 is other designated port. It is so easy. Also, in the switch 1, gigabit 01 is the root port in the switch 1, okay, this port, and gigabit 02 is the designated port. In the switch 3, gigabit 01, okay, is alternate port, and gigabit 02 is our designated port, this port, or is our root port in the switch 3. That's it. This is the story of MST instance 2. Then MST instance 3. In the MST instance 3, you know that the root bridge is the switch C or switch 3. Because of that, let me to copy this root bridge. Okay, here, this is the root bridge. Both of its ports are designated ports. This is designated, and also this is designated port. Then about the switch 1, gigabit 02 is the root port, and gigabit 01 is the designated port. Okay, and also about the switch 2, the gigabit 01 is alternate, and gigabit 02, okay, this interface is the root port. Let me to show you, and we can compare our result with the show commands here. First, we can start from the MST instance 1. This is the MST instance 1. In the show spanning tree MST1, we can see this is the story of MST1. As you know, in MST1, we have 10 VLAN 1 to 10. And this bridge, okay, is the root bridge of MST1. As you know, this is the BID or the MAC address of the switch 1. And this is the priority 24,576 plus 1, the MST instance number. Okay. Gigabit 01, gigabit 02, both of them are designated ports. A state of both of them are forward, and the cost according to the long cost pass method, okay, is 20,000. And here we have other information. Also, in the switch 2, show a spanning tree MST1, it can show us that again we have 1 to 10 mapped VLAN. This bridge has this BID, has this MAC address, and also this priority. Finally, we have this BID, and you can see the information related to the root bridge here. And after that, gigabit 01 is the root port, gigabit 02 is the designated port. It is okay. In the switch tree, show a spanning tree MST1. It can show us that again we have MST1, gigabit 01 is the root, and gigabit 02 is the alternate port. Everything is okay. Now, let me to talk about the STP instance 2. First, switch 1. Show a spanning tree MST2. As you can see, now if we have MST2 instance 2 and VLAN mapped are 11 to 20. As you can see, gigabit 01 is the root port, gigabit 02 is the designated port, and this switch is not the root bridge. In the switch 2, show a spanning tree MST2 can show us that we have 11 to 20 VLANs mapped to MST instance 2. Gigabit 01 and gigabit 02, both of them are designated port, and this switch is the root bridge for MST instance 2. And finally, in the switch tree, show a spanning tree MST2. It can show us that again we have similar information. Gigabit 01 is the alternate port and gigabit 02 is the root port. Finally, MST instance 3, show a spanning tree MST instance 3. In the switch 1 can show us gigabit 01 is the designated port, gigabit 02 is the root port. And after that, here on the switch 2, show a spanning tree MST3 can show us that port 1 is the alternate and port 2 is the root port. And finally, in the switch 3, show a spanning tree MST3 can show us that here we have the root bridge and gigabit 01 and gigabit 02 are designated ports. So easy. Actually, now we have only 3 STP instances, but we are using this 3 STP instance for 30 VLANs. You can use for more than this. Actually, with only 3 STP instance or 4 STP instance, we include the STP instance 0, we can, for example, create multiple topologies for many VLANs. We don't need to bind VLAN to STP. When you are binding the VLANs to STP, actually you are increasing the STP instances number. Okay. Also, you know that here we are using only one BPDU series for informing the information related to the instance 0, instance 1, instance 2, and instance 3. All right, now let me to show you some useful show commands when we are using MST. The first is show a spanning tree or show a spanning tree MST instance number that you have used. And the second, show a spanning tree MST, for example, interface gigabit 01. Look at here. Now we have 3 STP instance, okay, in the switch 1. Or actually 4 STP instance include STP instance 0. About the STP instance 0, you know that switch 1 is the root bridge of STP instance 0 because it has the lowest bridge ID. And because of that, the port of switch 1 is designated port, the port gigabit 01, and this port is designated in the STP instance 1 also, because in the STP instance 1 the switch 1 is root bridge. In the STP instance 2, the port 1 is the root port, and in the STP instance 3, the port 1 gigabit 01 is the designated port. Here you can see the state of this port in each of the STP instances, and here you can see the cost and also priority number and also VLAN mapped for gigabit 01 in each STP instance. It is so informative, okay? In the switch tree, for example, if you use show a spanning tree MST interface gigabit 02, you can see this interface in STP instance 0 is block, in STP instance 1 is again block or alternate, in STP instance 2 is root port, and in STP instance 3 is designated port. As you can see, we can for example, discover many useful information from this command. Okay. Also, in some cases, maybe you want to tune some parameters like the cost, like the port priority for one interface in only one STP instance. You know that in the traditional STP or in the RSTP, we can use a spanning tree, VLAN 1, then cost, or a spanning tree, VLAN 1, then, for example, port priority. Here, again, you have all of these options. Only you should use a spanning tree MST instance number, okay, then cost, or for example, if you want, you can configure priority. Look at here. For example, In gigabit 01 or in the switch tree, as you can see, show a spanning tree MST interface gigabit 01 has different costs, has same cost in all of these three instances. Maybe for some traffic engineering, you want to change the cost of gigabit 01 in the instance, for example, 1. Look at here, in the instance 1, the switch, the gigabit 01 is the root port and the gigabit 02 is the, for example, block. Let me to change this behavior only for instance